In this problem, we're going to continue looking at the hydrogen atom. Now the question reads as such: what is the maximum wavelength of light which will ionize hydrogen? In essence, what that means, if we're going to be ionizing something, that means that the end level is going to be going to infinity. So we're going to start at n equals 1, so the first state, and then we're going to move the electron to the infinite state. So the energy of the light that we're looking at is going to be equal to the energy to send the electron to infinity minus the initial energy that we're starting with. And the equation we're going to use is E sub n is equal to a negative 13.6 electron volts times z squared, not z squared, all over n squared, which is going to be the level we tend to send this at. And so if we write this equation out, so we have a negative 13.6 electron volts times z, which is going to be the atomic number. For hydrogen, it's going to be 1, divided by, now the level we're going to send this at, n, is going to be infinite squared. Minus, now we need to plug into that for our ground state. So it's going to be minus, so the minus is right here, and then another minus here. This becomes 13.6 electron volts. Z, once again, is going to be 1 because the atomic number of hydrogen is 1, divided by, now the state we're starting at is going to be 1, so this becomes 1 squared. Now, infinite squared is a really large number. It's infinite squared. And so if you take a number divided by a really large number, this in essence is going to become 0. So E of the gamma is going to be equal to, we have a negative and negative, it's going to be positive 1, 1. So this is going to be 13.6 electron volts. Now, that doesn't tell us the wavelength. We can convert this into joules. 1 electron volt is equal to 1.6 times 10 to the negative 19th of a joule, and that's going to equal 2.176 times 10 to the negative 18th joule. Our lambda is equal to hc over our energy. We have our energy there. So this becomes 6.626 times 10 to the negative 34 joule second, times our speed of light, which is 3 times 10 to the 8th meters per second, divided by now the energy we have, which is 2.176 times 10 to the negative 18th joule. Joules cancel, seconds cancel, We're left in units of meters. And I already converted this, becomes 91.2 nanometers, which is going to be in the ultraviolet regime. So we're going to have to send in ultraviolet radiation in order to send the electron, which is in the first state, to infinite. Infinite means it's infinite. It's a long ways away from the nucleus, and thus we've essentially removed that electron, thus ionizing it and making it a cation or +1. If you have any questions on this problem or any other problem, please let me know.